Welcome back to Sailing El Jaleo. This week we're going to run through the spank machine for a third time as we try and solve our alternator issue. We've had a couple of them burn up on us so far, and hopefully this time the issue will be put to bed. So I guess we might as well go ahead and get right into it. Grab a drink, climb aboard, and let's get going. Hey y'all, we are back in Delaware City and I've started on projects, and the first thing I want to try and get knocked out while we're still in the water is to get a working alternator. So here's the new alternator and here's the old one that burned up. You can see if we put the mounting brackets side by side, there is a discrepancy. So this pulley does not line up with the pulley on the engine, on the main crankshaft, so that is a problem. I came up with a couple of ways that I could possibly fix it. One is extending this pulley out, but I fear that would put pressure on the ball bearings on the shaft. I don't think that's the right solution. Another option was to change the mounting bracket on the engine, but that involves welding, and that's not, that's expensive, and I don't know that that's the right answer either. So I came up with a third option just now, and these are identical sizes. They're just shifted a little bit, so you can see how this housing, the housing extends out here further than this housing, and then you've got your cooling fan, whereas this cooling fan is flush with the housing here, so it's off by this much, just this width of the fan. And on the back too, this extends out just a hair longer than this. So what I think I'm going to do is I'm going to take all of the guts. These are the exact same size. I measured them with calipers. So I'm going to try and take all of the internals out of here, the stator and the rotor, and put them in this. I'm going to reuse this section of the housing that's got the mounting bracket with the proper spacing, and I'm going to use this stator here, and I'm going to take out the rotor and try and get it in here if possible, which I think it should be possible just using this pulley setup. So I don't know if all that's possible. I think that's the best way to go about it. The only thing I'm worried about, I've changed the stators out before. The only thing I'm really concerned about are the rotors. I haven't been able to remove a rotor successfully. There's some trick that I'm just not aware of. So when I get them disassembled, I might take them up here to the marina to see if they can swap out the rotors. Otherwise, I might have to take it to an alternator shop to have them do it. But I think that's going to be the easiest solution, that with the least expense, the cheapest option to get the new alternator working. So I'm going to go ahead and get started on taking these apart. And there you heard the basic plan. So I'm going to try and take the guts from the new regulator and pack them into the very small section of housing from the old alternator that mates to the engine, so everything will line up nice. So let's hope that works out. Now I already know if it works out, but you don't know, so let's collectively hope it works out. So one thing right off the top before we get too far in the weeds here is I apologize for any dings or buzzes you might hear from my phone. Normally I would have turned my alerts off, but Linus is at the vet today. He's getting his teeth cleaned and a tooth extracted, so they're going to call a couple of times today, and we don't want to miss that. So we're worried about the big guy, and we want to know how he's doing. So I apologize if I have to leave abruptly for that. So for those of you who haven't been following the channel for years, who don't know the sordid history we have with alternators, I'll give you the quick and dirty rundown. So when I purchased EJ was built in 1983, and her electronic systems are from 1983. So most everything in the boat was run off of DC power, which is optimal. You don't have conversion losses. You want to run as much stuff off of DC as you possibly can when you're using a battery bank. So very, very logical system. Now I had different thoughts in mind. I didn't want to convert the bulk of the boat to AC. Absolutely not. I still want to run as much stuff off of DC as I can. But there were a couple of things that I wanted to change. So originally all of the cooking in EJ was propane. So with propane, Propane is an explosion hazard. Now you do have to store your propane in a propane locker. It does need to be vented outside of the boat. So if you didn't know, propane is heavier than air. So if you're not careful with propane, if you have a leak, propane can get down inside the boat. It will stay inside the boat, and then when you have a spark, you have no more boat. It happens all of the time. Not all of the time, but it happens frequently, and it's a shame. So I just didn't even want to monkey around with propane. So I wanted to get the propane out. I wanted to convert all of our cooking to electric. So I have 2 induction cooktops, I have a convection oven, and I just added a microwave this year. So all of that AC load you cannot run off of the existing electrical that was in there. So what I wanted to do was to take out, EJ originally came with lead acid batteries, so I wanted to take those out and I wanted to install lithium iron phosphate. Now that's for a couple of reasons. Lead acid batteries are very heavy and they're not very energy efficient from an energy density standpoint. So if you have a 100 amp hour lead acid battery, you can only use about half of it before the battery is dead. So if you've got a 100 amp hour battery, you can only use approximately 50 amp hours out of it. Now if you have a 100 amp hour lithium iron phosphate battery, you can use approximately 90% of it before the battery is dead. So you have a lot higher energy density at about half the weight. So it's just a much better system, or a much better setup. Now it's at least for what I was planning on doing. So, I had very ambitious plans. And also another thing was the freezer that was on EJ originally was run off of a compressor on the engine. So if you're sailing for long periods of time, you would still periodically have to run the engine just to keep the icebox cold, and I didn't want to monkey around with trying to do that dance. So I changed all of the refrigeration to electric as well. Now I was able to keep that DC, so that's nice, but still it increases the power load that you put on the entire system. So I installed the solar panels with the solar charge controller. I installed the wind generator with a charge controller for the wind generator. All of that worked fine. I did install a 3000 watt inverter to convert from DC to AC, and that powers all of the cooking appliances. So I got all of that in there. And one thing that I did not understand was the relationship between the alternator and the lithium iron phosphate battery bank. Now I knew that the alternator would recharge the lithium iron phosphate bank, but what I didn't understand was the fundamental difference between how a lithium battery and a lead acid battery charges. So the alternator is a 165 amp alternator, so if it's putting out, let's say, 90 amps, and the lead acid battery is fully charged, the lead acid battery can still accept charge while the alternator slows down its amp output. A lithium iron phosphate battery, on the other hand, when it reaches full charge, it shuts off like a switch. And if the alternator is putting out 90 amps and all of a sudden it goes from 90 amps to 0 amps, the alternator does not like that. And the alternator cannot survive that, as I found out going down Chesapeake Bay. Yeah, the smoke alarm started going off. I didn't see any flames, but there was a lot of billowing smoke from the engine compartment, so I think we had a little fire in there. But yeah, so that was our first alternator. Now, to get around that, there are a couple of different things that I came up with. Number one is they do make an alternator protection device. It's a little box that you wire into, and that will accept the load if your lead or your lithium battery shut off. But that didn't seem like a very good plan, because inside it said, on the actual instructions for the alternator protection device, it said this device can fail, and if it does fail, due to an excessive spike of power, there's no way to tell that it's failed. So that just seemed like a problem just waiting to occur. So what I decided to do instead was to install DC to DC converters. So what they do is they take the DC output from the alternator and they run it through a unidirectional, so they're isolated, DC to DC converter. Now the DC to DC converters work directly with all of the other controllers. It's all Victron components, so they all work together to charge the lithium iron phosphate batteries correctly. Whereas so the DC to DC converters will vary the charge depending upon the charge of the bank. So the charge output from the solar charge controller and the DC to DC converters is almost identical, so that it charges the bank uniformly. So that's a good thing. Now that didn't solve the problem of shutting off, because the DC to DC converters will still shut off. So what I decided to do, but actually it works a lot better though with the DC to DC converters, and you might be able to get away with just using those, because as you do go from bulk into, what is it, bulk, float, or bulk absorption and then float are the charging stages of the battery. So as you do get into, once you get out of the bulk stage and get into the absorption phase, the DC to DC converters do slowly ramp down the draw that they're requesting from the alternator. So I think you might be able to get away with just using those, but I didn't want to take a chance. So what I decided to do was I added a lead acid battery back into the system. So the power coming out of the alternator goes to bus bars, which go to the lead acid battery and to the DC to DC converters. So basically that lead acid battery acts as a sink. So if the alternator, or if the charge on the lithium iron phosphate side gets shut off too abruptly, then the lead acid battery is there to absorb that charge and not absolutely destroy the alternator. That was the theory. And so I actually switched all of the electrics from all of the electronics from the engine. I switched from the lithium iron phosphate bank. I had everything tied together, but I isolated the engine back to that one lead acid battery. So basically I use that as the starter battery for the engine, and I have since changed one other part of the system. I've also changed I had a lithium iron phosphate battery up at the front of the boat to charge or to run the windlass, but that was really a suboptimal setup because the two lithium banks were, one of them was just one battery, and then I had an 800 amp hour bank at the back of the boat. They were at the opposite sides of the boat. It was stressing out the small battery up front. So I split that off from the main system as well, and I now have a lead acid battery up front, and that's tied into the engine electrics. So I figured if for some reason the lithium iron phosphate system eats itself, the two most important things that I need is the engine and the windlass. Everything else I can live without. So that was the plan for the reason why I isolated those systems specifically. So that worked for years. Now the problem was I had this 40-year-old alternator, and it had burned up in Chesapeake Bay. So I could take it apart. I could get the stator and the rotor apart, but I couldn't get the rotor out of the housing. And so I bought this new alternator that I'm trying to install now, but I just couldn't get it to work on the engine, and I hadn't figured out to change the housings out yet. So I found a rebuilt alternator that was from the 80s. Now this original alternator is no longer made anymore. The new one that I bought was a Chinese knockoff, so who knows how long that's going to last. But I found a rebuilt one that was 40 years old, and I took that apart. I could get the rebuilt stator out, but I couldn't get the rotor out of the old housing. So that rotor is burned up because it was on fire. So I have a rebuilt stator and a burned rotor in the housing, and now on the new system, the DC to DC converter system. And that actually worked for 2 years. I'm surprised it lasted that long. I should have addressed this way earlier, but it is what it is. So the second alternator burned up this year in St. Augustine. I don't know if it's just a diode or something, but I know I don't want to mess around with 40-year-old alternators anymore. I just want to get this new one installed. So that's why that's how I came up with this new plan. And the problem is getting the rotor out. So I could get everything apart, and it's fine. You know, I could always get the stator out of the old housing, but I could never get the rotor out. So the rotor goes into a bearing, and that bearing is compressed fit into the housing, and I could just never get it out. So what I actually had to do, so first I took it to the marina just to see if they could get the rotor out, and they had no idea. So then I took it to an alternator shop to see if they could get the rotor out, and they had no idea. They wouldn't even touch it. So I ended up finding a machine shop just, you know, a couple miles down the road, and asked them if they would try and press the rotor out of the housing. So they were able to do that. $20 later, I got my rotor and my housing back, and then I actually could change out the entire deal. So that was nice. And there is a bearing in there, so I took the 40-year-old bearing out. I put the new one in there, all of the new housing, or all of the new guts on the old housing. And it's interesting, there are slight variances between the two, but not anything major. So I actually had to put the alternator together and take it apart and put it back together 4 times. A, because I'm a dumbass and I didn't plan correctly, and then the other was just some parts were just slightly off. So there are 4 bolts. They're like probably 6-inch long bolts that hold the entire thing together. And the new bolts were about maybe a 1/4 of an inch. It wasn't even a 1/4 of an inch. Maybe a 1/16 of an inch longer than the old bolts. So it was hitting the fan on the pulley assembly. So I had to take the new bolts out and put in the old bolts, and that worked. They were just short enough that they didn't hit that cooling fan. Then I mounted it on the engine, and then I couldn't get to the wires, so I had to take the whole thing apart again and rotate it, you know, 180 degrees. Would it be 180? No, 120 degrees. So I rotated it 120 degrees, so the regulator and all the connections were on the top. It was just, so I had to take it apart and put it back together and take it apart. And you know, when you're working on an alternator, it's kind of a pain in the ass because it's designed to spin, and you have to stop it from spinning in order to tighten down certain parts. So it's a little bit of a challenge, but we got everything back together and it worked. Yeah. So I put the alternator in. The only thing I'm not 100% sure on yet is the tach. So I do have to find the output from, since it's got an internal regulator, there is an output for the tach. I have to find that. Once I get back in the water and I can fire up EJ, I should be able to run the engine and get a voltmeter on there to figure out which connection is for the tachometer. But other than that, it works fine. I did test it, so I put it in. This was when we were still in the water. That's the first thing I worked on when we got back to Delaware City. We were in the water for about the first month, so it gave me enough time to go ahead and get this whole thing done. And I got everything put back together. It ran fine. I tried it with 2 DC to DC converters. I didn't fire up all 3. I didn't want to push it too hard. And I actually don't think I'm going to run all 3. The DC to DC converters, I think they're 360 watts a piece. It's either 320 or 360. I think it's 360. And so that's 720 watts if 2 of them are running, and that's plenty for us. So yeah, I don't think, unless we're really in a pinch, then we can run 3 DC to DC converters. It's nice, you can turn them on, turn them off. You know, you can really kind of control the output from the regulator, so it's not running soup to nuts. You know, I don't know, what does that even mean, soup to nuts? I don't know where I heard that, but so it's not running full bore the whole time. I don't even think that made sense, but but anyway, so it is working. I did run it for about 20 minutes. I did a test where I could ramp it up so that it would get to, you know, the battery bank would be fully charged and it would cycle down, and it shut off fine. The lead acid battery accepted charge. The DC to DC converters switched from bulk to absorption, then to float. Sorry, I'm having a brain fart. So yeah, so I'm cautiously optimistic that this is going to work. And besides, now we have the generator, so there's really no reason to push the alternator too hard, because if we do get in a situation where we're in Matanzas Inlet for 4 weeks again, we can always fire up the generator. It's so much nicer to have the generator. I used to spend an entire day running from the Matanzas Inlet up to the Crescent Beach Bridge, then back down to Matanzas Inlet, up to Crescent Beach Bridge. It's, I don't know, maybe 4 miles between the two, but I didn't want to keep going through the bridge every time and pissing them off, so I was just doing little loops, back and forth for 8 hours to harvest power, and that's just a pain in the ass. And your wear and tear on the boat components, the diesel, you're that much closer to an oil change, you're that much closer to a transmission oil change, so why not just run a stinking generator and get it over with? I know that's not very glamorous, but that's what we decided to do, and I think, yeah, it worked out well last year. And, yeah, so that's the plan. Cautiously optimistic that this is going to work. I guess I'll know in about a month. We're about a month now from heading back to Florida, so I guess we'll see. All right, hope y'all are well. And that's all we have time for this week. I would like to give a massive shout out to my Patreon crew. Without your guys' support, I wouldn't make these videos. And my Patreon crew is Joan and Juddy Judnick, Val and Chris Alcorn, Denise and Eli Sackett, Sherry Erickson, Deb Shaw, Matthew Spotton, Peter Allen, and Natalie Linehan. Thank you guys so very much. Your support really means the world to me. I do have one legacy patron member, and her name is Joan Linbow. Unfortunately, she has passed on, but she lives on in our hearts forever. We really miss you, Joan. If you are interested in joining our Patreon crew, there is a link in the description down below, and that'll take you to our Patreon page where you can sign up. And there are hundreds, literally hundreds of extra videos and photos of our travels, and I try and keep everything there up to date and post at least once or twice a week, so it gives you a little peek behind the curtain. If you do like our videos, please like, comment, and subscribe. That'll help us out more than you'll ever know, and that actually doesn't cost you anything, so hit that like button. Alrighty, I hope you all are well, and we'll see you next week.